In this video, we're going to take a look at exponents with integer bases. So the key thing to pay very close attention to on these problems is whether or not there are parentheses. When there are parentheses, the negative symbol is going to be captured as part of the base. So here, since there's parentheses around -2, it means that the base is -2. So that's the thing that we're multiplying by itself 5 times. And another thing to pay attention to is whether the exponent is odd or even. In this case, the exponent is odd. So when you have a negative base and an odd exponent, your final answer is going to be negative, and here's why. Each pair of negatives is going to multiply to a positive, right? -2 times -2, +4. -2 times -2, +4. But then, since the exponent is odd, we're going to have an extra negative at the end to flip it back to a negative. So our final answer on this one is going to be -32. Now what I would really do instead of writing it out is just, I know 2 to the 5th power is 32, and since it's the base is -2, and it's an odd exponent, it'll be -32. Next up, -1 to the 5th power. Now here there's no parentheses. So before the negative can even attach to the 1, the exponent is going to pounce on it and perform its operation. So the base here is just 1. The negative doesn't get to attach before the 5 attacks. So you do 1 times itself 5 times, and then at the end, put the negative back on. So our final answer is going to be -1. Now it just so happens for this one, it'd be the same answer if it was -1 to the 5th power. That would also be -1. But if there's an even exponent, it'll change things up. So for example, these two will be different. If we have here -1 to the 6th power, we have a negative base, -1, and we're multiplying -1 by itself 6 times. Every pair of -1s multiplies to a +1, so our final answer will be +1. But if we didn't have that parentheses there, then the exponent would attack the 1 first. We would do 1 times 1 times 1 times 1 times 1 times 1, get +1, and then the negative would attack and make it -1. So you can see that in this case, the parentheses really do make a big difference. And perfect, here's an example, just what we were talking about. If there were parentheses around the -1, our final answer would be +1. But since there's not, then the 4 attacks before the negative can even attach to the base. The base is just 1, so we do 1 times itself 4 times, and then the negative attaches, and our final answer is -1. Here we have a parentheses, so the base is -10. We have an even exponent, so we're going to do 10 times 10 and get 100, and it's going to be a positive 100 because, again, it's an even exponent, and a negative times a negative makes a positive. We got parentheses, so negative is part of the base. Our exponent is odd, so our final answer is going to be -1. The first two -1s cancel out and make +1, but then we have this extra -1 right here that'll flip it back to a negative. Finally, two more, -3 to the 3rd power. So here, the negative is not part of the base. The base is just 3. So we do 3 times 3 times 3, we get 27. Then the negative attaches, and our final answer is -27. Finally, -2 squared. Another example where the negative is not part of the base because there's not parentheses. So we do 2 squared first. 2 times 2 is 4. Then the negative attaches, and our answer is negative 4. If this problem had been this, negative 2 in parentheses squared, then it would have been positive 4, because then it would have been negative 2 times negative 2. So the key for this assignment is determining whether there are parentheses or not.